Today, friends, we will be solving the slope deflection problem. So we'll be solving a very important question of slope deflection. So if you are new to this channel, you can like, share and subscribe this channel. Before starting the lecture on the slope deflections, one thing I want to mention that winning means being unafraid to lose. So on that note, let us start today's important problem. Now friends, we have the problem as shown in figure. We have a frame in which there are two fixed supports and the UDL of 40 kilonewton per meter is acting at the top. So this is the very important question of theory of structures and we will solve it out today. Now friends, at first we need to assume the different points in the given frame. So we assumed and named as A, B, C, D in the given frame. Now we need to first find the fixed in moment. So for the solving of slope deflection, we need to find the fixed in moment. So we find the fixed in moment in AB, BA, CD, DC, BC and CB. So as there is no external load in section AB and CD, so the fixed in moment in sections AB, BA, CD and DC will be 0. And there is and in section BC you have external load of 40 kilonewton per meter, that is UDL. So for that case, we have the formula of the fixed in moment in BC as minus WL square by 12. So if you solve this, it will give you minus 120 kilonewton meter. And likewise in section CB, there is WL square by 12 plus is the formula. And if you solve this, 120 kilonewton meter is the answer. Now friends, we need to write the slope deflection equations. So we know that the moment in any section AB using the slope deflection equation is the fixed in moment in section AB plus 2EI by L 2 theta A plus theta B minus 3 del by L. So this is the general formula. Okay, so the fixed in moment in section AB is 0 plus 2 EI. So relative stiffness EI is 1 in the section AB. Okay, so and the length of the section AB is 4. So 2 into theta A. Here is the fixed support and fixed support. So it will not be rotated. So theta A is 0 plus theta B minus 3 del by 4. Here we assume that the frame, when applied with the horizontal force, so it will be moved or it will be swayed by delta. So delta is the amount of sway the frame exhibits due to any horizontal loads. So del with the sway here, and if you solve this, MAB will be 0.5 EI theta B minus 0.375 EI del. So this is the moment in the section AB. Similarly, using the slope deflection equation in BA, so moment in BA, MBA equals to fixed in moment BA plus 2 EI by L into 2 theta B plus theta A minus 3 del by L. So if you just substitute the values as theta A equals to 0, and if you solve this, MBA equals to EI theta B minus 0.375 EI del will be the moment in BA. Likewise, using the slope deflection equation in BC and CB. So in first BC, MBC equals to fixed in moment plus 2 EI theta by 2 EI by L 2 theta B plus theta C minus 3 del by L. So here in this section BC, we have the deflection, that is the sway in the section BC is 0. So 3 del by L is 0 in this section BC. Okay. So the final equation of moment in section BC MBC comes out to be minus 120 plus 1.33 EI theta B plus 0.667 EI theta C. Likewise, in section moment in CB will come out to be 120 plus 0.667 EI theta B plus 1.333 EI theta C. Likewise, using the slope deflection equation in CD and DC. So first we apply the slope deflection equation in CD. So MCD equals to fixed in moment plus 2E into, so your I is given as 2I. So 2I by L. So L in this section CD is 6 meter. So you substitute 6 here, and 2 theta C. Theta C will also offer rotation plus theta D. Theta D is the in section D at point at joint D there is the fixed support, so that will be 0 in that case, minus 3 del by L. So 3 into del by L is 6. So if you solve this, MCD will come out to be 1.333 EI theta C minus 0.333 EI del. Likewise, if you solve for DC, MDC equals to 0.667 EI theta C minus 0.333 EI del will be the expression for DC. Now friends, we need to apply the joint equilibrium equations. So at joint B, the summation of moment at joint B equals to 0. So we have MBA. So at joint B, we have moment along BA plus moment along BC equals to 0. So you have already determined MBA plus MBC. So you need to substitute the values of MBA and MBC in this expression, and you will receive equation number 1 as 2.333 EI theta B plus 0.667 EI theta C minus 0.375 EI del equals to 120. So let this be your equation number 1. Similarly, friends, using the equilibrium equations in joint C, that is summation of moments at joint C equals to 0. So we have the MCB plus MCD equals to 0. So substituting MCB and MCD equals to 0, we will obtain 0.667 EI theta B plus 2.667 EI theta C minus 0.333 EI del equals to minus 120 as your equation number 2. Now friends, we have obtained 2 equations in which there are 3 unknowns. So 2 equations and 3 unknowns cannot be solved. So we need another extra equation so that we can solve the unknowns. So for that we have considered the free body diagrams of the columns. So column is AB and column CD. So if we assume that the horizontal reaction at A and at fixed support D as shown in a figure, so to balance that we have just balance the sections in AB and CD. Okay, so these will be the moments that will be arising in the sections. So if you just solve this, HA into 4 equals to, that is the anti-clockwise moment, that should be equals to the clockwise moment MAB plus MBA. So the horizontal reaction force occurring at A will be the HA equals to MAB plus MBA by 4. Likewise, SD will be equals to MCD plus MDC by 6. Okay. Now friends, if you use the summation of forces in x direction equals to 0, rightward direction as positive, then you will receive HA plus SD equals to 0. So HA is given as MAB plus MBA by 4 plus SD is given as MCD plus MDC by 6. equals to 0. So if you substitute the respective values of moment in AB, BA, CD and DC, then you will get the equation number 3 as 4.5 EI theta B plus 4 EI theta C minus 3.583 EI del equals to 0. So this is the expression, this is the equation 3. So now we have 3 unknowns and 3 equations. So that can be easily solved. So you need to put all these equations in the calculator and solve. So these are the expressions that are, these are the 3 equations that you have got, and in which there are 3 unknowns. So you need to solve it out. So friends, solving these 3 equations, we can obtain EI theta B as 72.58, EI theta C as theta B as 72.58, theta C as minus 60.149, EI del equals to 24.01. So these are the 3 required three parameters, and you need to substitute these 3 parameters to get the respective moment in all the sections. So friends, substituting these values in the slope deflection equations, we obtain MAB as 27.28 kilonewton meter, MBA as 63.57 kilonewton meter. So MBC, so MBC will be just numerically should be just nearly very equal, but should be opposite in the sign. Okay, so magnitude same, but its sign would be coming just in the opposite sense. Okay, likewise, so 63.57, so MBC will be coming very close to 63.57. so sometime you may occur that 63.594041, so something like that, but that magnitude should be coming very near about, so that you can confirm that your calculation is correct. Okay, likewise MCB will be 88.23, and CD will be minus 88.23 kilonewton meter, and MDC will be minus 48.11 kilonewton meter. So friends, with these values obtained, now we will draw the bending moment diagram. Finally friends, we need to draw the bending moment diagram of this given frame. Okay, so at first we draw the skeleton structure in which AB, BC, CD frame is given. Then at AB section, so going to the AB section, the moment in AB is given as 27.28 kilonewton meter. So this is positive, AB is positive 27.28, so we located positive inside the frame. So 27.28 has been gone under, so inside 27.28 we located it. So going through BA, so BA is 63.57, so BA is 63.57, so you need to move at joint B. So at joint B 63.57, so it is came as to be a positive. So but actually the value of, so you are going from left to right, so MBA will be plotted in the negative sense. So we just write it in negative sense because it is not going serially. So AB, BC, CD, so these are the serial ways. So if you're just going from back BA or CB, this is drawn as opposite sense. So in just the opposite sense. Okay, so MBA is drawn in the negative sense. So 63.57 has been written outside. Okay, so there is no load, so they can be joined by simple straight line. So joining them, we got the figure as shown in figure in section AB. Likewise in BC, at joint B we have moment of 63.57, that is negative, so we have plotted in upward direction. Likewise in CB section there is 88.23, but CB is taken as to be negative, so 88.23 upward. Okay, likewise in CD section there is 88.23, so 88.23, that is negative, so we just write it as negative in outward sense 88.23, and in DC minus 48.11. So actually DC shall be just in the opposite sense as the value is obtained 48.11. So just we write in as positive and inside the frame. So joining them we just obtain as shown in figure. But major concern here we have is we have the uniformly distributed load in section BC. So we all know that if you have a uniform UDL load, then the BMD will be always a parabolic curve. So we need to have a parabolic curve in the figure. So we know that the maximum moment for the bending maximum moment in case of UDL is WL square by 8. So solving that we obtain 180 kilonewton meter as the maximum bending moment. So we located 180 in the 180 kilonewton meter in the diagram, and we plotted the diagram as shown in the figure. So friends, this is the way we can solve and analyze the problem in which the frame structure is given as the indeterminate structures. So this is the way we can solve out by the slope deflection method.
So friends, if you find this video as useful, you can like and share to your friends. And for such videos, stay tuned to this channel. Thank you. We will meet soon in another video.